So still solving polynomial equations in factored form. Number 7 is in factored form, although you might want to rewrite the x minus 3 quantity squared as x minus 3 times x minus 3, and then that's equal to 0. If you notice, each of these binomials are the same. If you set x minus 3 equal to 0 and solve that, you should get the same solution if you solve x minus 3, the second x minus 3 equal to 0. Add 3 to each side, x equals 3. You would get the same thing over here. This is what's known as a repeated root or a repeated solution. You don't have to write it twice. You just write it once. X is equal to 3. And then on number 9, 2t plus 8 times 2t minus 8 equals 0. We have to apply and use the zero product property. Set 2t plus 8 equal to 0, and then set 2t minus 8 equal to 0. Solve the first equation by subtracting 8 from each side. 2t is equal to negative 8. If we divide each side by 2, t is equal to negative 4. We do something similar for the second equation, but we add 8 to each side. 2t equals 8. If I divide each side by 2, t is equal to 4. So two solutions here, negative 4 and positive 4 are your two solutions. And then the last thing that we need to discuss is factoring a polynomial. So to factor a polynomial, what we want to find is what's known as the GCF, or greatest common factor. And then I just want to take a look at one part at a time. So on number 13, the two terms of the polynomial are 6x squared and 3x. I want to find the greatest common factor between 6x squared and 3x. At some point or another, you found the greatest common factor between constants or numbers. So looking at the numbers, 3 and 6. The greatest common factor, the largest number that goes evenly into both 6 and 3 is 3. So that's part of the greatest common factor. Now I want to take a look at the variable, x squared and x. Okay, if you have a common variable, which you do here, x and x, the GCF will be the variable to the lower exponent. So the lower exponent here is actually 1. There's an exponent of 1 here, exponent of 2. So 3x is the greatest common factor between 6x squared and 3x. But these two expressions aren't equivalent. If I'm going to factor a polynomial, I want to write an equivalent expression. So I factor out, which is basically taking out 3x from each of the terms. And then you have to figure out what's left or what's remaining. So if you factor out 3x from 6x squared, you kind of work backwards here, like 3 times what is 6? And it's 2. What do you multiply x by to get x squared? And it's x, because 3x times 2x is 6x squared. What do you multiply 3x by to get 3x? And it should just be 1, because if you distribute it, this is factored form here. This is factoring the polynomial. If you want to check and see if your answer is correct, 3x times 2x is 6x squared. 3x times 1 is 3x. So this is factoring the polynomial, finding the greatest common factor between each of the terms. And number 14, kind of the same thing. Just take it one part at a time. The greatest common factor between 4 and 20 is 4. And then the greatest common factor between y to the 4th and y cubed, they share a common variable, it's y. And then the lower exponent is exponent of 3, or cubed. So 4y cubed is the greatest common factor between each of the terms that we started with. But to make them equivalent expressions, we need to figure out what's remaining in each of the terms. 4 times what is 4? And it should be 1. You could write it, or you actually don't need it, as you'll see. What do you multiply y cubed by to get y to the 4th? Here's where you need to know your properties of exponents. Should be y. Or another way to figure that out is just subtract the exponents. 4 minus 3, 1. So y, or 1y. And then 4 multiplied by what is negative 20? It's negative 5. And then y cubed times 1 is y cubed. So negative 5 times 1 is just negative 5. This is factored form. Maybe take a minute, try number 16. So on number 16, the greatest common factor is just g to the 6 or 1g to the 6. 7 and 2 don't share a common factor other than 1. And then the common variable is z, the lower exponent is 6. And then what's remaining, or what you should multiply this by to return it to its original polynomial, 7z, and then plus 2. If you distributed the z to the 6th to 7z plus 2, you would end up with 7z to the 7th plus 2z to the 6th.